what we are looking at today are the word problems for the law of cosines. And what we're going to look at first, we have to try to draw a picture. In this picture we have here, we have drawn this pond with people on either side of it. And we have two distances we know and an angle we know as we've gotten from this picture. And we need to figure out what this distance between the two people are. You should notice it's a side angle, side triangle. That's why we're doing law of cosines. So always start, when you have side angle, side, start with the angle that you don't know. So c squared, and that's why we get a squared plus b squared minus 2ab cosine c. Okay, what we want to look at now is, as I plug in the values that I know, I can plug in, I try not to get ahead of myself. I plugged in 102 for A, 83 for B, and then 81 degrees here for cosine of C. So I'm kind of running out of room. That should be 81 degrees. Slide this guy over a little bit. There we go. Okay, so when I simplify that, I can just punch this all straight into my calculator and get c squared equals is 14,644. Take the square root and get a final answer of 121.01 feet as a result. Okay, so just to go one step at a time, figure out exactly what you need. Here's another example. This one's already worked out. I would suggest you try to work out with it and see if you can make it happen. What we had here, this should be cosine of 60 degrees here. What we ended up doing, same thing. We drew a triangle based on what we knew. We got 120 and 90 based on how many miles it went based on its speed and how far after 2 hours. You should get about 108 miles in the end for this problem. Now number 3 is a different kind of problem. This is talking about a boat race. Triangular course with buoys A, B, and C, and it gives you the distance between all 3 of them. So that makes this a side, side, side triangle. So with side, 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 we don't know where to start. We always are going to start with the smallest number, the smallest side or smallest angle. That's what's going to give us the least possibility for a mistake. So when we do that, that means side A, the way I have it drawn here, should be the smallest. That means angle A is the smallest. I'll plug in the values that I know. When I plug in those values, this is what I should get. Now here's the thing to pay attention to. When I plug this in, this whole guy here is one big entity. I cannot break it up. I need to try to simplify everything else in their entirety. So I'll do 1750 squared, I'll do 3250 squared and 4000 squared. Those will each be numbers and I can combine them. And then I'll do this multiplication. When I do, these are the values that I get. About 306,000, or 3,062,000 I should say. This ends up being about 26 million minus this ends up being 26 million as well. Okay, when I simplify, to simplify and get cosine of A by itself, I need to do that by, subtracting this guy to the other side. So when I subtract to the other side, my result is negative 2.35 million. I get negative 26 million on this side, and I should have said it should have been 23 million, and 26 million on this side. To get cosine A by itself, I'll divide both sides by that negative 26 million, get 0.9038. And then to solve and get angle A, I take the inverse cosine of both sides to get 23 or 25.3 degrees. So that means this right here was 25.3 degrees. Now it wants to know the measure of all 3 angles. Well, now you should notice you have an angle side pair. So because of that, you can go and use the law of sines now, which is what we'll do down here. So start with the angle side pair, the sine of 25.3 in the 1750. And then I always want to pick the smaller of my 2 remaining sides. That way I don't have to worry about the potential of getting a side-side angle 2 triangle possibility. So when I do that, cross multiplying, and then I'll divide to get sine B by itself. Sine of B will equal 0.793. And I do the inverse sine to get 52.5 degrees. So that's what angle B is here 52.5 degrees. Now to find the last angle, all I have to do is add them up to 180. So I already knew 2 of the angles. I need to find the third. So these 2 angles I already know add up to 77.8. So I'm going to have, it should be, 102.2 degrees as my final angle. All right, 2 more examples just to look at and kind of talk through real quick. This one is a side angle side for this one with the pitcher's mound. A baseball diamond or softball diamond is always a perfect square, and the pitcher's mound just cuts that right angle in half. That's how I got 45 degrees. And from there, side angle side should be really easy. I just have to plug and chug all this in Just always check and make sure you're getting the side that you want, in this case, side A. And number 5, finding the length of 2 diagonals of a parallelogram. So I drew the parallelogram here, and then kind of redrew it twice, one with this longer diagonal, one with the shorter diagonal. And you have to solve 2 different side angle side problems. So in this one, when I took this diagonal BD, I have side angle side with 65 degrees in the middle, and in this one, side angle side with 115 degrees in the middle. So really the only difference between these 2 problems should be the angle that you use. But you do get 2 different answers, and one diagonal is indeed longer than the other. So there's the examples that we did for law of cosines and word problems, and hopefully you are in good shape and ready to roll.